Welcome back, Math 30-2, to your second lesson on exponential and logarithmic functions. In today's lesson, we're going to be looking at the exponential equation and seeing how each aspect of it, especially the a and b, influence a graph and what it looks like when we graph. So we're looking at this a and this b, and we're seeing how do they determine graphs? How do they influence the graph, each one? Starting off, we're going to look mostly at a here. As question A states, state the values of a and b for y is equal to 2x and y is equal to 1/2 x. Now if I write this out, y is equal to 2x, for this one, 2 to the power of x, we look at the a, and back to this equation here. Is the a influenced by the x? No, it's not. Only the b is influenced by the x. The a has no association with the x. The a must not be influenced by the x. And here, the 2 is being influenced by the x. Now, what does that mean? The 2 must be influenced by the x. What is a? If a is 0, then no matter what, the equation is equal to 0. Y is equal to 0. But that's not true. There's an imaginary 1 outside. Therefore, a is equal to 1. It's that little 1 outside that's being multiplied in. Most time when we have 1, when a is equal to 1, we just don't write it in, because we don't write in 1 multiplied by 5, we just say 5. Now we look at our b value. B is going to be equal to 2, because it's the one influenced by the x, by the exponent. Okay? Let's look at the second one. Y is equal to 1/2 to the power of x. In this case, same idea. Our a value is equal to 1, because the x is referring to both the 1 over 2. And my b then must be 1 over 2, because it's the one being influenced by the x. It's the one that's the base to the power. Part b says to complete the graph, so we're going to complete this graph and graph it out, or complete the chart and graph it out. Now, if we remember this one, and we're looking at 2 to the power of x, 2 to the negative 3, this is kind of from last lesson. It's the same thing as 1 over 8. Why? Because this is the same thing as 1 over 2 to the 3, which is 1 over 8. So we're going to put in 1 over 8 here, right? Reciprocal rule from last lesson. This is the same as 1 over 4, and this is going to be 1 over 2, 1, because anything to the power of 0 is 1. Remember, and this is going to be 2, 4, 8, 16. Okay? Now we have to graph it. I'm going to count by 2s. Okay? So this is 1, 2, 3, 4, and count by 2s here. 1, 2, 3, 4. So that's -1, -2, -3, and -4. And we're going to count here. So we have 1, 2, 3, 4. So that's 1, 2, 3, 4. Now, looking at this, do I need to do my negative axis? Is there any way I could get a negative number? If this is positive, if a is positive, is there any way I could get a negative number? Knowing that b cannot be negative because, well, just take it out. We're not going to do negative exponents. So can b, or can we have a negative number here? No, not for this one, because a is positive. We will not have any negative numbers. So we're only looking at the top part. Because any positive number to the power of something, that's a positive multiplied by a positive. It's always going to be positive, so we must always have positive numbers. Now we look at the first one is 1 over 8. So at -3, we have 1 over 8. Well, that's so small, it's going to be close to 0, right? Next one is 1/4. Well, 1/4 is half of a half, so I'm going to put it in the middle there. The one after that is half, and then 1. Then we keep on going up to 2, then we go up to 4, and then 8, and then 16, so it's way up there. So now I'm going to just put all this one in green. Because I have more than one graph on the same grid, so I'm just going to color code it like that, so I know it goes forever that way and forever that way. Okay. Let's take a look at this one. 1 over 2. So 1 over 2 to the -3. Well, that's the same thing as 2 over 1 to the power of 3. Remember, reciprocal. It was like the positive exponent. Makes everything easier. That's going to be the same as 8. Well, then this would have to be 4, 2, 1. This is 1 over 2, 1 over 4, 1 over 8, 1 over 16. So I'm going to start graphing out here quickly. Plug this in. 1 over 16, that's super small. 1 over 8 is right there. Next we're going to have 1 over 2. And then we have, oops, 1 over 8, 1 over 2. I made a mistake here, sorry. This one's 1 over 2. This is going to be 1 over 4, 1 over 8, 1 over 16. And that's 1. Next one is 1 all the way up is 2. And this one here is going to be 4. And we go up. So we take a look at this. And it looks like that. Now, these two graphs here, I drew one longer than the other. But notice how they kind of look the exact same, except there's a mirror. They're reflected along the y-axis, or where x is equal to 0. That's our line of reflection. Why is that? Is because this one and this one here, both of those numbers, they are reciprocals of each other. 1 over 2 is the reciprocal of 2. And it's kind of neat, so we have a little reflection there. Okay? Now, let's take a look at here, part D says, find the asymptote. Well, the asymptote is something that gets, when the numbers, a graph gets so close to a number, but it never touches it, it gets infinitely close but never touches it, that's the asymptote. So normally it starts curving to it and it gets lines up forever. So first of all, we're going to look at the domain and range. So the domain, I like to think of domain as D, range as R, and in the alphabet, X comes first before Y, and in the alphabet D comes before R. So domain refers to our X's, range refers to our Y's, because first in the alphabet. I always start off like this. I'm just going to set them up. And we have X, we have a max and min. Okay, we do our two L's on either side, max and min. Now, is there a minimum for the X? No. The X goes forever in that direction. Is there a maximum? No. X will go forever in that direction, in this direction. So X goes forever here, and X goes forever there. Therefore, I don't have a minimum, and I don't have a maximum. Therefore, X is just an element of all real numbers. Now let's look at the range of the first graph, the green one. Now, I'm going to set up the same way. We have my Y, and I'm going to look at a minimum and a maximum. I look at it this way. My Y value, is there a minimum? Well, I get close to the x-axis, but I never hit it. Therefore, my Y value can never be 0. So there is a minimum. But can it equal to 0? It cannot equal to 0. That's impossible. Even if I have x to the 2 to the negative 5 billion, I'm saying x is 5 billion, that's still 1 over 2 to the 5 billion, which is 0.000. It goes on forever, but there's still something there, right? So it's not quite 0. Now I look at my maximum. Is there a maximum? No, this goes forever up, therefore there's no maximum. But y is still an element of all real numbers. Okay? Now we're going to look at my x-intercept of the graph. My x-intercept. Does it ever cross the x-axis? No. So there is no x-intercept. What is my y-intercept? The y-intercept is 1. Okay. What is my asymptote? Well, it never actually crosses or touches the x-axis, so it's the y is equal to 0, and that's my x-axis. If we look at this line here, that's my line of where y is equal to 0. My x-axis is the line of y is equal to 0. Next part is domain of this guy here. So let's do the same thing again. I'm going to go and make my little L's. So x, which way? Minimum. Is there a minimum for the x in this one? I look at it, it goes forever that way, doesn't it, eventually? Is there a maximum? No, it goes forever that way. So I'm going to erase both my max and my min. I know there's no max, no minimum. Therefore, x is just an element of all real numbers. X could be anything in the world. Now we're going to look at my range. So range is referring to y. All right? Let's see, is there a minimum for this guy? Going down. Well, there is. I can't go below this line, can I, with this pink guy? So there is a minimum, it's 0. But can I equal to 0? No, I cannot. So I'm going to erase that equal sign on the bottom. I'm just going to have this. Now let's look at my maximum. My max goes forever up, and it goes forever up. Therefore, there is no maximum. So y is just greater than 0, so y is an element of all real numbers. So is there an x-intercept for this graph? No. The y-intercept of the graph is same thing as the other ones, right here, 1. Now, the equation of the asymptote is y equals 0, because that is where x can never be. Okay? It's the x-axis is my asymptote. So now it says complete the following in words of increasing or decreasing. So 2 to the power of x is an example of a increasing function. Why? Because we go 2 to the power of x. We're going uphill. It is increasing. So we're going uphill, therefore it is an increasing function. Next one is saying 1 over 2 to the x is an example of a, look at this, we're going downhill. From left to right, we're going down, so it is decreasing. All right? We always go left to right. So here it says, notice that the graphs 1 over 2 to the power of x and 2 to the power of x are reflections of each other. Why is that? That's because of, do you notice what these? Those are reciprocals. They're reflections. And there's nothing in front. Now, we are going to explore b in this one where y is equal to 1. So using your graphing calculator, sketch the following equations. So I want you guys, using your graphing calculators, to sketch each of these. Okay? And what happens to each of these ones. Well, I'm going to look at this one, the first one. I'm going to just give you a little generalization. This is going to look like that, right? The next one here is going to look even more. It's going to kind of look like this, let's say. Okay, it's a little bit lower. And then we're going to end up going 1 over 3. So just do everyone and graph them out yourselves. And I'm going to go and see what they look like. In our calculator, it's going to kind of graph like this. Okay, so this one here should be steeper than that one. There's a reason why I know that. This one here is going to be going decreasing. It's going up this way. This one here is also going up that way. But now how they look will change. So if I put this in my calculator, how am I going to graph it? I'm just going to go y is equal to 3 to the power of x. Graph. And it looks like that. I'm going to change my window. I'm going to put my max to 20. Oops. To 10. My y max to 20. And I'm going to leave this at 0. I'll put negative, just so I can see everything. Okay? So now I could really see how it gets bigger and smaller. Okay? Now let's try the next one. It's going to be 10 to the power of x. So that one is. So this one comes up a lot straighter. It's skinnier. It goes up steeper than the other one. And even if I zoom in to this part here, you'll notice something as well. So there's my first one. And look at the second one. It should be lower and then steeper. Okay? So like if we think about it, 1 over 10, so x to the 1, negative 1, is 1 over 10. That's a lot less than 1 over 3. 10 to the 1 is bigger than 3 to the 1. Therefore, this is steeper this way. It's very steep. It takes a lot longer to get bigger. Then when it does, it shoots up really fast, a lot faster once it hits 1. So, okay? Now, you take a look at these. These are going to be going just in the opposite direction. And so that would be 1 over 3. And the other one will kind of look like this. This is the reciprocal. This is a reflection of this guy, right? This guy here's a reflection of that guy. So this is going to be my solid, and this is my light one. All right? And that's what those would look like there. And notice how they all have the same intercept. So let's continue this. It says, the value of b affects the steepness as it increases or decreases. So when b is greater than 1, the curve increases more sharply. Okay? When if b is between 0 and 1, as b increases, so really it decreases more sharply, okay? So if b is greater than 1, well, which one's smaller? As b increases, this is increasing, it decreases more sharply. Okay? Without using a graphing calculator, make a sketch on the grid above of the following graphs. So we're going to now try and graph these two here. I'm going to just estimate what they look like. So y is equal to 5 to the x. So 5 to the x. So we still have the intercept there, and we want 5 to the x. This is going to be very steep. It's going to shoot up very fast. I'm just going to go, if this is 1, I'm going to put my 1 there. Negative 1. So it's going to be like that, and then it shoots up very fast. Now the next one is 0.2. I'm going to say that's going to go like that. Okay, why? Because b here is greater than 1, and as b increases, my value here, it goes up more sharply. This makes it go up steeper. This makes my hill steep. Very gradual and then steep. This one here kind of makes it not so steep. It's just a very gradual incline. Whereas this one here is nothing and then all of a sudden, straight up. Okay? So the 5, this bigger this number means, well, the faster it goes up. The smaller the number, the longer it takes to go up. Oh, 0.2. Whoa, I made a big mistake there. 0.2 is a decrease. Whoops, sorry. I thought it was 2. So 0.2 is going to go this way. Alright? Because this is the same thing as 1 over 5 to the x. And it's the exact same increase, it's just a reflection. It's so much easier if you put it in terms of, so one goes like that, the other one goes like this. They are reflections of each other, because this is the same thing as 1 over 5 to the x. Sorry about that. Next one. Verify the solution of C using a graphing calculator. Now you're going to use a graphing calculator and see what happens. These are going to be reciprocals because this is just the opposite. So this one is decreasing, this one's increasing, because this is between 0 and 1. This one here is greater than 1. Next it says, state the x-intercept for each of the graph in the form y is equal to b to the x. The x-intercepts, well, there are no x-intercepts. There are none. It is an asymptote. Next one says, state the y-intercept for each of the graphs. Y is equal to b to the x. Okay, so take a look at this. It's always going to be 1. Okay, so it's always at y is equal to 1. That's the y, or y-intercept is always at 1. Now it says, state the domain for each of the graphs in the form y is equal to b. Well, the domain is, for both of them, no matter what, when we're looking at b, we are looking at x, such that, now I look at this here, for both of this, there is no, x is just an element of all real numbers. There's no max, there's no min, as we found out before in the last one. Now stating the range. So my range is my up and down. So we're looking at y, and we're just going to do this, y, y. Now looking for the y's for both of these. Is there a minimum? For both of them, the minimum is 0, and it cannot equal to 0, so I'm just going to make it not equal to 0. And then, is there a maximum? No, there's no maximum. It goes up forever. So then, the y is an element of all real numbers. That's it. So now state the equation of the horizontal asymptote for each of those. So that is when y is equal to 0. Okay, because that y is equal to 0, that's my asymptote. So that's everything for that one. So here's a special equation. I'm not really going to go into this. If you want, you can look it over and punch it into your calculator. It's very rare to see these. Next one is, consider the following functions with equations of the form y is equal to AB to the x. So now we're going to look at A and what A does. Okay, so I'm going to give you 10 minutes, pause the video, and go over what A does. Then we're going to do this class example 1 together. So welcome back. So here we're going through class example 1, and it says, describe why none of these graphs could work for this. So I'm going to first look at, for that equation, so I'm going to first look at my A. A is equal to 5. That means my y-intercept is equal to 5. Okay? Well, I look at this here. Automatically, this one's not, y-intercept's 4, and that's 5. Therefore, my y-intercept should be 5. It's 5 times, if x is 0, 5 times 1 is 5. So this is my x is 0, therefore, y-intercept should be 5. So far, we're still looking at these ones. Next part, I'm going to look at this, and that's 4. If b is 4. And I'm looking at this here. There is no adding anything, so I know my graph, my asymptote is equal to 0, or is y is equal to 0. So we have an asymptote here. This crosses the asymptote. So therefore, this one's off. Now the next one, it says b is equal to 4. This means it is increasing. This one's increasing because, and it's not plus or minus anything, so this is increasing, therefore, this cannot work as well. Because it's increasing, so my graph should go this way. So that's why that one's off, and that's why none of those work. Okay. So now we're going to explore A, where A is greater than 0. Or sorry, where A is less than 0. Okay? So here we go. Explore the graphs, all of these. Alright? Now this one here, and it says using a graphing calculator, sketch each of the graphs on the same grid. So these are, they have each graph right here already graphed, and we're going to sketch them on your own graphing calculator. So how do the graphs in this one, these two graphs, compare to those? Alright, so these here are all the positives. Now here we have some negatives. So I'm going to go A. So here are my graphs in A. And now we're going to do the negative ones. Okay, so let's try this. Let's see 3 to the power of x. And we're also going to go negative 3 to the power of x. So that's really like saying A is negative 1, because it's negative 1 multiplied by 3 to the x. So I'm going to graph this and see what we get. So this one graph is going up, and the next one is down. I'm going to just zoom 6, get my standard window. There we go, one's there, and one is there. So these two are very similar. What's happening though? There's a reflection on the y-axis. Let's try the next two. If I said 3 to the x, I'm going to say the next one was 2 multiplied by 3 to the x. Okay, and let's try this one. So this is going to be 2, and I'll put bracket. Oh, negative 2, bracket 3 to the x. I'll go to the bracket, close that. And let's graph this. So once again, we're just comparing this one and that one. I'm going to graph it. See what happens. Wow, once again, they look almost the same, but there's a reflection again on the y-axis. So I want you just to continue this. And what happens? Continue this table. See what you end up getting. Okay? Okay, now welcome back. So the characteristics of the function, f of x is equal to a b of x. Now we look at that, And so the x-intercept. So here we're looking at, so here we're just going to summarize everything we learned from all of our explorations that you are supposed to finish. So you should have finished the one before that I just kind of started off with you. Now it says the y-intercept is, when we're always looking at this equation, what is the y-intercept? The y-intercept is always the a value. Where the x-intercept is, there is none. There is no x-intercept. Now the x-axis is always, so the x-axis is where y is equal to 0. Can y ever equal 0? No. No matter what when we have exponents, y cannot equal to 0, so it is a asymptote. It's a horizontal asymptote. Okay? Now the next one says the domain is, well, the domain is always what? We could always go forever left and forever right. Is always x is an element of all real numbers. Okay? The range depends on the value of a. So for here it says if a is greater than 0, so if a is positive, my range is y is greater than 0. Okay? And y is an element of all real numbers. Now, if a is less than 0, then y is less than 0. And y is an element of all real numbers. Because as soon as the a is less than 0, we have a flip on our x-axis. Alright? Remember that? So when a is negative, there's a flip on the x-axis, and it's always below. It's curving down like this below. Now the next one says, the values of a and b determine which of the graph is increasing and decreasing. Okay? Which is increasing or decreasing. So the first one, if a is greater than 0 and b is greater than 1. Okay? So we want from quadrant 1 to quadrant 2, so we're going from left to right, because our quadrants look like this. 1, 2, 3, 4. Okay? So we're going from quadrant 1 to quadrant 2. If a is greater than 0 and b is greater than 1, we are increasing. Okay? So here it's saying if a is greater than 0, but b is between 0 and 1. So that would be like 0.5 or 1 over 2. We are going to end up going like that. For this one, if we have 0.5, well, 0.5 to the power of negative 3 is the same as 2 to the power of 3. So that's a big, we're starting off big, and we're going small. So this one here is decreasing. For this, I would just use an example of each one. If you really need to and you're stuck, use an example in your calculator. Think of, okay, 0.5 to the negative 3. Is that above 0 or below 0? If it's above 0, well then that means you're decreasing. Okay? And then try positive, 0.5 to the power of 5. Well, that's pretty small. Because 0.5 times 0.5 is 0.25 times 0.5 is, whoa, you're just getting small. Next one is 0.125. So here we go. We have, now it says it's less than 0, and it is greater than 1. So we're going now, we have to go from quadrant 3 to 4 because a is less than 0. As soon as a is less than 0, we know it's a negative. That means here's my x-axis. It is going below my x-axis. Okay? So now b is greater than 1. Well, when b is greater than 1, it's increasing. But now we're flipped over this x-axis, so it's going to go like that. It's going to decrease. Okay? Now it's saying a is greater than 0, or sorry, a is less than 0, so we're still down here, and it's saying b is between 0 and 1. Well, when b is normally between 0 and 1, our graph looks like this. It's decreasing, right? But now we have to flip it, so it goes like that. So in other words, if we go left to right, it increases like that. So it is increasing. Okay? Now the value of b also affects the steepness of the graph as x increases. So when b is greater than 1, the curve gets steeper as b increases. Okay? So if b is between 0 and 1, so if I said 1 over b, right? That's the same thing. B is 1 over b. Then the curve gets steeper as b decreases. Think of it in terms of fraction. So if I have this as 1 over 0.1, that's b, well then that's bigger because that's the same thing as 10, right? But if I have 1 over 20, well that's very small. So that's why I like to think of it as 1 over b. As b, the curve gets steeper as b decreases, okay? Does that help? So I'll see you tomorrow. Hopefully you had no problem doing that one part of the exploration by yourself. And good luck as we see you tomorrow and work on some of these questions together.